all of you to this very special edition of Business and Policy Dialogue. I say this special for two very obvious reasons. One, this is a dialogue that we are hosting on the eve of the World Environment Day, 2 days from now. And we are discussing a very important and timely topic, which is climate change and its impact on glaciers. And the other reason it's also special is because at ISB, one of the things that we do well, amongst many things, I suppose, is to work with our partners. And so we're very fortunate today to have the British Deputy High Commission Chandigarh as our partners for this event. This is a topic that is of interest to all of us. Even if it isn't, it should be of interest to all of us. And I'm very fortunate to have my colleague, Dr. Anjal Prakash, who's the Research Director at the Bharati Institute of Public Policy at ISB, lead the discussion today. He will, of course, introduce the other panelists as well and the topic. This is also, when I say topical and timely, is also because this is an event that this is the second in the series of events that we are doing with the British Deputy High Commission in Chandigarh. About 6 weeks ago, we did another webinar on climate change and its impact on agriculture, and it was very well received. All of this in the run-up to COP26, which we know is just a few months away. So we hope that some of these events, inform us better in terms of where we stand, and more importantly, inform us better in terms of some of the actions that we need to take up rather urgently, if I say so. I won't be, again, like I said, getting into details of introducing the panelists here, but I just want to extend a very warm welcome to Professor David Hanna, Dr. Ulka Kelkar, Dr. Miriam Jackson, Sheikh Kunal Satyarthi, and of course to Anjal. But before I sort of request Anjal to take over, it's my great pleasure to welcome the Deputy High Commissioner in Chandigarh, Caroline Rowett, to offer a few remarks. She needs no introduction, as the cliche term goes. At least to us here at ISB, because in her very short stint of just over 3 months that she's been here in Chandigarh, we've already collaborated. We've had her visit our campus twice. We've hosted a minister from UK in March under her leadership. So I think, Caroline, if this is under lockdown, second wave of COVID, if we are able to accomplish so much in 1 quarter, then I'm only excited about what we can do going forward. But over to you for your remarks. Thank you.
Guru, thank you very much. Yes, actually, that's well said. Now I think back, we have achieved a lot in a very short period of time, given the restrictions that are here. That's really given me a boost. So thank you for reminding me of that. But anyway, to move on. So I'm delighted to welcome you all today to the Business and Policy Dialogue on climate change and glaciers. And I'd particularly like to thank ISB for their cooperation with the Deputy High Commission on the webinars in the run-up to the COP26 later this year, as Guru has already said. And I'd also like to thank the panelists for sharing with us their expertise on glaciers and the important role they play. It's a subject of particular relevance in this region, where we have glaciers in Himachal Pradesh and Uttarakhand, where we saw the devastating impact of rising temperatures on glaciers in February this year. The benefits of tackling climate change are numerous and in the interests of us all, including cleaner air, healthier communities, sustainable economic growth, energy security, and a safer, more stable world. And lack of knowledge is no longer an excuse. We have more information than ever before to guide our actions. Recent reports have detailed exactly what is needed to achieve a climate-resilient net zero future and the solutions that will help us get there. We must listen to the scientific community and act accordingly. As countries begin to recover from the coronavirus pandemic, we must take this opportunity to tackle climate change at the same time, to build back better and greener. It is possible to deliver green recoveries across the globe that bring in good jobs, investment, and groundbreaking new technology. To keep the temperature of the planet under control, limiting its increase to 1.5 degrees, as agreed in Paris 5 years ago, science dictates that by the second half of the century, we should be producing less carbon than we take out of the atmosphere. And action has started. The world is moving towards a low-carbon future. Around 70% of the world economy is now covered by net zero targets, up from less than 30% when the UK took on presidency of COP26. And the UK is leading the way. Over the last 30 years, British governments have grown our economy by 78%, whilst cutting emissions by 44%. In 2012, 40% of our electricity came from coal. That figure is now less than 2%. And we will completely phase out coal power by 2024, and will end the sale of new petrol and diesel vehicles by 2030. We're introducing legally binding targets to restore nature and radical reforms to agricultural subsidies. We have a 10-point plan for a green industrial revolution to help us reach our climate commitments while creating thousands of highly skilled jobs. We're doubling our international climate finance to help developing nations with over £11 billion a year by 2025. And we'll be planting trees on 30,000 hectares of land in the UK per year by 2025. India is also taking impressive action on climate change and the restoration of ecosystems, including plans to install a massive 450 gigawatts of renewable energy and to restore 26 million hectares of degraded and deforested land by 2030. This commitment to climate and nature makes us natural partners. Our Prime Ministers agreed at their virtual summit last month to strengthen joint work on clean energy and climate change and develop a new joint partnership on forests. But moving on to glaciers, our topic for today. I've witnessed the impact that global warming is having on them at first hand only a few years ago. I was on holiday in Chamonix in France and went to visit the Mer de Glace near Mont Blanc. In 1988, it would have taken 3 steps down to reach the glacier. When I visited in 2018, only 30 years later, I had to walk down 500 steps to reach it. It was a long way down, and it was a very long way back up again as well. But as I walked down, I passed signs marking the decrease in the level of the glacier from 1985. It was sad and shocking to see how much and how fast it has melted in that short space of time. Closer to home, my current home being Chandigarh, incredibly, there are over 30,000 glaciers in the nearby Himalayas, forming part of intricate geographic and climate systems and feeding some of the most important river systems, providing water for millions of people. But changing climate patterns and rising global temperatures are melting the glaciers. Studies have shown that if carbon emissions are not cut drastically, about a third of these glaciers will disappear this century with a devastating impact. There's a lot we can do together. To inspire us along this path, we are keen to share experiences by setting up events like today's session to raise awareness and inspire action. So without further ado, I'll hand over to Dr. Paquette to start the discussion. Thank you.
Yeah, thanks so much, Caroline, for your very interesting talk and setting the background. So I would not be able to take this further in a sense that you have really beautifully put the canvas on which we will be discussing. Thank you so much for that. So it's time for me to then straight away introduce my panel, and very esteemed panel for the day. We have Shri Kunal Satyarthi. He's the Indian Forest Service officer, and he's presently the principal of the Central Academy of for State Forest Services, which is under the Ministry of Environment, Forest and Climate Change, Government of India. So welcome, Kunal, on board. If you could put on your video, we could also see you. So Kunal, welcome on board. We have the second speaker of the day, Dr. Miriam Jackson. Miriam is the program coordinator, the Cryosphere Initiative, under the River Basins and Cryosphere programs of AC Mode, the International Center for Integrated Mountain Development, based out of Kathmandu. We have very eminent personality, Ulka Kelkar. She's a prominent personality. She writes a lot on the media, as well as part of the World Resources Institute. She's the director of the climate program there. Very eloquent person, one of the strong voices for climate change. And last but not the least, we have David Hanna. He's a professor of hydrology, UNESCO chair of water science, and at the University of Birmingham and in United States and United Kingdom, and he joins us live from there. Thanks so much, David, for joining us, and I enjoy reading your paper and the scientific that you do, especially the one which is to me from water to me to water for all. You're trying to the democratizing the water value is a very interesting paper that we've written recently. So thank you all of you for joining us, and we will start the conversation. The whole issue of glaciers and climate change. This issue has been on the block for quite a lot of time, in a sense that couple of decades before that this whole issue has been started, especially in the context of global warming. I remember in 2017 when I was invited to be part of the IPCC special report on oceans and Glacier, and Miriam and I both worked on this report where we looked at two interconnected systems, the oceans and the Glacier, which is the frozen part of the world, and the glacier is part of this thing. And we concluded that the climate change, is impacting our glaciers, and especially in this session, we'll be talking about the Himalayan glaciers because this is something that is impacting people and the lives of the people more closer home in the South Asian continent. And so, before we take this forward, I'll request each of my panelists to just give us an opening remark in terms of the issue that is at hand and how they view about these issues, and we'll go forward. And the format is that we will have a question and answer, kind of keeping it more conversational, and followed by we will open it up for question and answer from the larger people who have joined us. And I was told about 200 plus people have already registered for this webinar. Plus, there'll be people who will be joining live for this webinar. So I look forward to some very intriguing questions from the general public as well. So let me first go over to Kunal. Kunal, over to you for opening remark.
Thank you, Anjal, and thanks to the British High Commission and the ISB for giving this opportunity to share my thoughts. And I will be doing, I have handled Climate Change Center for 3 years, but in the presence of David and Miriam and Ulka, I'll not venture into that dangerous domain. I'll let my forester and botanist, forester by profession and botanist by academics, speak about this issue. Maybe glaciers data I have about all the rivers and the current data also, but that I'll share a bit later. I'll not bore with that. So as far as the forester and botanist in me is concerned, I'm worried about 4 or 5 things which are very pertinent. Having worked in the Himalayas for around 20 years and trekked to those passes and those glaciers, some of these important points that I've noticed, and just like to highlight them initially, and then I'll share all the data about what is happening to the glaciers. Everybody knows, river-wise, I can tell you what has gone wrong. But the major issue that is affecting people and forest is because of the glacier loss is the change of crop pattern. And you already had a webinar on that, and I have seen people just changing crops without knowing the technical term called vernalization, such a difficult thing to pronounce. They don't know that that requires, most of the Rosaceae family requires a minimum temperature to flower, and the plants, trees don't flower, and people move to different crops. And that is a classical change because those crops require a lot of water. It's a vicious cycle, and a lot of fertilizers and insecticides and pesticides, and the whole of the mountains, Himachal Pradesh and Uttarakhand, have gone through this problem. So that is my first take. That is, I don't know how to mitigate that. We did a lot of study, and we'll have to go back to our traditional grains and crops. That will save us from climate change. That will also give us enough nutrition to survive things like corona and stuff. So that is my first point. Second point, from a forester's perspective, it is that we are having, it's not a very conclusive report now, but we have a lot of projects running looking at the timberline. Is actually the timberline moving into the alpine pastures? Are my lower conifers climbing into the higher conifer zones? And that will take time. That will take 120 years for the Citrus deodara to climb into Abies pinrose area. But in the initial reports that we see, the trees are climbing. And that is scary because they will have to go up to the mountain and tumble the other side, almost like what they did during the glacial era. But trees are moving by regeneration, not by physically moving. They're shedding their crops, and the crops are regenerating in higher zones than normal. And that is true about faunal species also. I had a recent picture, same spot in the Uttarakhand mountains, you have a picture of snow leopard. Same spot, you have a picture of the normal leopard, which has never happened in the history of this. May have happened, but not captured on the camera at the same place. So this is causing a lot of disturbance. The third point I like to highlight, I'm not going to glaciers by choice because I know I'll go into the in a different zone. The third point is the change in phenology, and trees are flowering very fast, and it is proven. Trees are flowering fast. I live in a city which is in the foothills of Himalayas in Dehradun, and I do a lot of bird watching. Birds are migrating at erratic times. If the flowers is flowering, if rhododendron is flowering 2 months early in Mussoorie mountains in the Himalayas, the birds and the insects have to reach there in time, and that is causing a lot of confusion. I see birds at very odd times. A lot of migratory birds are in a hurry right now. They got delayed and they're going up because this year the snowfall has been good in the mountains. So I don't know. Some guys were migrating 2 months earlier last year, and this time they are migrating 2 months late. Must be a lot of problem for the insects and the birds. So I thought I'll highlight some of these erratic weather conditions. Soon, July, August, I'm waiting for that. All the newspapers will be full of cloudburst, flash floods, so many people gone, and this will repeat. This will keep on repeating. And I don't want to go into Gloff, and I'm aware about the number of moraine dammed lakes that are sitting in the mountains of Uttarakhand and Himachal Pradesh. I have live numbers. We monitor them on LISFORM satellite platforms. I do not like to scare people, but there are a lot of these lakes sitting on the mountains, ready to come down. You'll have more of them coming out. I think David will, from the amount I know about that, David would be highlighting that future, but I'll give you more ideas about what is happening on the ground reality. So that is my, I know I'll not speak anymore. That is my introductory remarks. I'll speak about glaciers a bit later. Thank you so much.
Yeah, thanks, Kunal. We'll come back to you because a lot has to be discussed with you, especially coming to the Himalayan states and what the impact it has. Let me cross over to my colleague Miriam Jackson, my former colleague from EC Mode. Miriam and I also worked, as I said, in the SROC report by IPCC, and she's now joined as coordinator of the Pasture initiative. This initiative is monitoring glaciers across 8 countries in the Hindu Kush Himalaya region. So, Miriam, over to you for your thoughts, your opening remarks.
Okay, thank you very much, Anjal, and thank you for the invitation. So, hello, everybody. Good afternoon. And talking about glaciers is actually one of my favorite things to do. I started studying glaciers in the late 1980s in Antarctica. And at the time, there wasn't much known about Antarctica. And it was very hard to get there. It took actually a couple of weeks just to get to Antarctica. It took another week or so to get to our field site. And we didn't even know what our field site really looked like from the air. And we got the first high resolution satellite. When I say high resolution, it was like 1 kilometer resolution satellite images about 1989. And this was amazing because we could actually see the area where we were studying. And that was such a help. And then I got a PhD and moved to Norway and was studying the glaciers there. And there was a lot longer time series. I've been studying glaciers there for decades. And people lived a lot nearer to the glaciers. It was easier to get there. You could, once you had flown or driven somewhere, you could then walk the rest of the way or ski, or even using helicopters and snowmobiles. So it was very easy. And then I was involved in a project working on glaciers in Bhutan. And at the time, there were no regular measurements on glaciers in Bhutan, so we started those. And it was very different. Again, we didn't know much about the area. To get to our field site took nearly a week. The people I was working with, most of them none of them had been there before. Most of them had never seen a glacier before. And so it was a lot of effort to start these measurements on one glacier. Now in the Himalayas, in the Hindu Kush Himalaya, there's about 54,000 glaciers. It depends how you actually count them, but anyway, there's thousands and thousands of glaciers. And it was a huge amount of effort to measure just one of them. In recent decades, there's been a lot more measurements from satellite images. So the resolution now is improved immensely since my time in Antarctica. Access to them is a lot easier. And they're very, very useful. There's been some really useful studies to tell us what's happened to glaciers in the past couple of decades, also in the Himalayas. But if you want to know what's happening locally, we really need to actually get there and measure the glaciers. And we can see the glaciers are changing, actually in some areas much more than others. And if you look at globally, again, from the IPCC report that Anjal mentioned, actually the glaciers in the Hindu Kush Himalaya are changing less than the global average. So if you look at the Caucasus and the European Alps, and also Carolina mentioned this, glaciers are changing much more rapidly. However, we also have to look at the implications. How many people are living downstream of these glaciers? How many people are depending on the water for their irrigation? And how able are they to respond? How resilient are people? So it's not just how much the glaciers are changing, but what's happening downstream, who's using the water, and how well are they able to adapt to change? And Kunal also mentioned this. Is it easier to look at people's crops failing and say, oh, you should have changed a few years ago, or to say to them, look, in a few years, this is going to happen, and you need to start thinking about that now. Glaciers respond to climate, and usually this is in a fairly simple way. If the temperature increases, then the melting increases. However, it depends when you get this increase. If you get a change in winter temperature from -15 to -10, that doesn't mean very much. It's still cold, it's still frozen. If you get a change during the melting season from 0 to +2, it's a much smaller change, but it has a lot more effect. You're going to get a lot more melting because of that. You can also get some strange things happening. If you get warmer weather, it could be wetter weather. It could be wetter during the winter, and then you get more winter precipitation, or what we call snow. So although the weather is wetter, you could get more snow and the glacier is growing. So there's a lot of intricacies that we need to understand in studying glaciers. There's even some, especially in the Karakoram and Svalbard, that we call surge-type glaciers. So these glaciers have an instability and they suddenly advanced. This isn't related to changes related to climate, it's an imbalance. So we have to understand what is happening with individual glaciers so we can try and see what's going to happen in the future. So we're looking at glaciers here, and there's a very good reason for that. Glaciers are amazing, they really are. And if you haven't seen one, you should go and see them. But remember, there's just one part of what we call the cryosphere. So as we're talking about glaciers today, remember that we should also be thinking about other frozen water on the Earth. So this is snow cover. Snow is seasonal. So it's a lot harder to measure it and measure trends in it and what's happening long term than it is with glaciers. There's also something called permafrost. This is frozen ground, and permafrost is pretty much invisible. When there's changes in permafrost, the effects are very visible and also very dangerous for many people. But we should remember that we not just focus on glaciers, but also think about the rest of the cryosphere. Also, for studying glaciers, it's very important to do long-term measurements. You can't really go and measure a glacier for a year or two and get anything useful. It's also, so that means that instead of running out and measuring 10 different glaciers, it's much better to measure one and keep those measurements going and expand if you can. We also need to coordinate the work. If you're going to have 10 different institutes measuring 10 different glaciers in 10 different ways, how do you compare those results? It makes it very hard, and also comparing it internationally. So we really need to collaborate in doing this work. And most importantly, when we have our data, we need to share the data. Thank you. I'll stop there.
Thanks, Miriam. Very informative, and the insights that you have, especially coming from the Hindu Kushima region, is really nice. And we'll have a conversation further as well. Let me just go over to Ulka Kelkar. She's the director of climate program, the World Resources Institute India, and they do a lot of data deciphering, in a sense that they also have a program which reaches out to general people. So Ulka, over to you for your opening remark.
Thank you very much, Anjal, and thank you so much to the organizers. It's raining very heavily outside here, so forgive me if you hear a lot of background noise. I wanted to start by mentioning a very recent report that has come out from the WMO, which said that in the next 4 years, there's a 40% chance that the Earth as a whole will breach this psychological threshold, as we say, of 1.5 degrees Celsius temperature, higher than pre-industrial levels. The important thing to remember over here is that for places like the Himalayas, this 1.5 degrees Celsius threshold has already been breached. Parts of our world are already warmer than the average, which is 1 degree Celsius. So this is a sort of backdrop against which we are discussing issues of glaciers, which are in some sense the most sensitive, in some sense the indicators of, the earliest indicators of change that is already happening. The second recent article that I wanted to talk about is a rather provocative op-ed by an economist. So I'm an economist by training, and economists like me should not be talking about glaciers. But Swaminathan Ankaleshwara Iyer, who has a regular column in the Times of India, surprisingly reviewed a series of research studies, journal papers, which were about the impact of glacier melt on downstream water availability in the Ganges River Basin. And actually, there were 3 studies. There's a study by Yu et al., which said that the contribution of glacial melt in the river flow in the Ganga is about 19%. There was a more recent study by Immerzeel et al., which was the sort of warning one, which said that 40%, as much as 40%, especially in the dry summer months, comes from glacier melt. And Swaminathan Iyer wrote about a more recent study Sorry, I'll just turn off my video. I think I have low bandwidth.
Yeah, that's fine.
Temporarily. Yeah. So Aminathan wrote about a more recent study by Armstrong et al., which found that glaciers contribute only 4% of downstream water availability in the Ganges. And the argument that they make is that there is a confusion between snow melt and glacier melt, and that the bulk of the downstream water availability will continue to come from the Indian summer monsoon rainfall. So there's nothing to worry about, was the rather provocative conclusion of this op-ed by this economist. In light of this, I think the point that Miriam made, which is what else is also changing, becomes very important. How is the Indian summer monsoon going to change with climate change? We don't know very much about how patterns of rainfall will change. Even if the aggregate does not change, the frequency, the proportion that falls in extreme rainfall events on fewer days, perhaps interspersed with dry spells, we don't really know for sure. How will winter snow change? What is the feedback loop as more snow melts and warming gets accelerated? What is the contribution to sea level rise, especially since more and more information is coming in about how ice sheets in Antarctica and elsewhere are melting from below, from where they're in contact with the water. And so there's a lot of now concern that in some sense, IPCC estimates about sea level rise are quite conservative, and the reality might be a little more worrisome. The second question that I want to ask beyond what else is changing is what is the impact on, for example, sensitive plants, animals, insects that depend on the cool water, the stream habitat that is fed by these glacial melt. These are, they support food chains, and we don't again know too much about what will be the impacts. The third question I want to ask is what is the impact on mountain dwelling communities who use these streams, springs that are drying, pasture land and farmland as well. When I did some field work with communities in Uttarakhand many years ago, they used to talk about how the snow in the winter was like, it used to be a protective layer which used to trap moisture in the soil. And they said they likened it to manure, something that enriched their soil. And now with snow melting earlier in the year, there are going to be a lot of impacts on local mountain dwelling communities. And as we know, particularly during this COVID crisis, when there is growing scarcity of resources, there is also growing inequity in terms of accessing those scarce resources. So this is something where economists, sociologists, anthropologists need to work much more in areas which are immediately downstream of glaciers, which we're not doing sufficiently of. And my last question is really about what is the impact on hydropower and on the sort of the clean energy economy of India that is dependent on things including hydropower. We had this severe event in Uttarakhand in 2019, which actually destroyed hydropower development and killed people who were working on those power systems. There was a similar event in the same area in 2016, where also a lot of rock and ice debris moved quite fast. So we also need to take these kinds of risks into account when we do siting of hydropower dams. And this becomes a very direct economic impact as well. I want to end with a more positive point, since Mr. Satyarthi mentioned birds. I was just reading, I think yesterday, about the alpine parrot of New Zealand, which was seen as a kind of indicator species. If the alpine parrot finds that its habitat is warming, where will it go? But they recently found, based on fossil and other evidence, that actually the alpine parrot used to live in the lowlands as well before. It was found in many other parts of New Zealand, and in fact moved to the mountains to get away from people. As we encroached into its habitat, it would reach to the mountains. So the positive story over here is that adaptation is possible, both in terms of natural species as well as in terms of human activities. The problem, of course, is that the rate at which we are, having these changes happening might just exceed our ability to adapt, or certainly your species' ability to adapt. So while all is not lost, I think now is the time to really take a serious look at whether we are closing all our options for adaptation. Thank you so much, Anjal.
Thanks, Ulka, very much. I think it's also important for us to raise questions than seek answers. And I think you've laid out very well in terms of the key questions that also we have to seek answers to. Let me cross over to David. David has been a professor of hydrology and has been writing the very scientific work that, David, you've been doing on these issues. So over to you for your opening remarks.
Thank you very much for the introduction. And good afternoon, everyone. It's a real pleasure to be part of this panel discussion on climate change and glaciers. Thank you very much to the organisers for the invitation and for putting together what I think is a very thought-provoking discussion. So as well as being Professor of Hydrology at the University of Birmingham, I also hold a UNESCO Chair in Water Science. And my research seeks to understand water cycle processes and impacts under climate and other drivers of change. So of particular relevance to this panel is my expertise on hydrology of glaciarized rivers. And this includes working on glacier climate, meltwater drainage and runoff processes. And we've been doing this through field observation and also virtual modelling studies. So I've been working in logistically challenging high altitude and high latitude cold environments for over 25 years, doing research on snow and ice covered watersheds across Europe's mountains, in the Andes, in the Arctic, in New Zealand, and also in the Himalayas, largely working in Nepal since the 1990s. But we have a current WMO funded project in the Uttarakhand Basin with colleagues at IIT Roorkee. So what I'd like to do in these opening remarks is to bring together this work to provide some reflections on glacier change and in response to climate. And what I want to do is to affirm a sort of overarching statement or a key takeaway point, which has already been made by others, but I want to make it very strongly that glacier shrinkage is driving global changes in downstream systems. And this is due to very strong coupling between our climate, the cryosphere, the hydrosphere, the geosphere, and the biosphere, including people, in these very sensitive environments. To illustrate this statement, I'd like to make 5 points about the importance of glacier-fed river basins and also the impacts that are occurring under climate and global change. The first point I'd like to make is that glaciers cover 10% of the Earth's surface, but they're shrinking rapidly in most parts of the world, leading to cascading impacts downstream. The previous focus, has already been mentioned today, has been often on sea level rise with lesser consideration of runoff and water availability. But these changes in hydrology are really vital downstream to ecosystems and also to people's livelihoods. And in terms of hydrology, glaciers import a really unique footprint on river flow, and glaciers are often the only water resource during the low flow season. The second point I'd like to make is that changes in river hydrology and also their morphology caused by climate-induced glacier loss are projected to be the greatest of any impact on any hydrological system in the world, with major implications both for those river systems and nearshore marine environments. The loss of snow and glaciers will result in distinct changes to the timing and magnitude of runoff peaks. As has been mentioned already, river flows are typically at their peak in the summer due to meltwater release, and they're really important in buffering during the dry season when precipitation is low and air temperature is high. So it's expected in the long term, after perhaps an initial increase as the frozen waters are released, that will be an ensuing what's called negative mass balance, glacier shrinkage, and that regular buffering that the glaciers provide to the annual water cycle will become less reliable in terms of the summer peak, and that the river flows will be much more sensitive or spiky to precipitation episodes. The third point I'd like to make is that current evidence indicates that as glaciers shrink and the hydrological regime alters, we'll also have changes to sediment transport, to biogeochemistry, and to contaminant fluxes in waters from the rivers into the oceans. So the changes in glaciers are going to disturb global and regional biogeochemical cycles. For example, at the global scale, there's a lot of ice-locked organic matter, carbon matter, and it's quite substantial. And it's unexpectedly high for what might seem to be quite barren, hostile environments. So the dissolved organic carbon concentrations are low, but because of the volume of waters in glaciers, they actually generate quite a lot of dissolved organic matter export. Also, the fine glacial sediments promote the process of nitrification, so glaciers can be net exporters of nitrate to downstream systems. But perhaps most significantly, and as picked up by the media, deglaciation may result of the release of legacy pollutants, which have been transported and stored in glaciers from industrial activities elsewhere, and these are being released into fragile ecosystems and impacting on vulnerable mountain communities. Fourthly, my fourth point, these changes in water quantity and quality have profound influences on the natural environment, including facets of biodiversity and the ecosystem services that these river systems provide. There's already evidence for biodiversity loss and perturbed food webs and disappearance of endemic species and reduced genetic diversity at regional scales. There are also impacts on the migration of fish through river corridors, which has significant economic impacts. Linked to this, the seasonal predictability of glacier response impacts upon a range of ecosystem services, spanning ecosystem provisioning, regulating, and cultural services. So glacier water storage and release is perhaps most prominent in terms of the provisioning of ecosystem services for people through, as already mentioned, navigation, hydropower, human consumption of water, irrigation, inland fisheries, tourism, and religious beliefs, to mention but a few. My fifth and final point, and this is hopefully a hopeful point, is that we need to realize that humans and society must adapt and try to mitigate these broad range of impacts that I've mentioned already as glaciers begin to reduce. So glacier loss will result in some quite interlinked effects on freshwater systems and on ecosystem services. And we need to really be careful in terms of thinking about the multifaceted and interconnected trade-offs we'll have to make in terms of decisions about how we manage in a sustainable way these precious water environments. So we need suitable and sustainable management strategies to develop and to have them implemented. So things that have already been mentioned, like less intensive water agriculture, thinking about natural storage within catchments in water stores other than glaciers, such as wetlands. And last, I would say, is the point that Miriam already made. I think the breadth and complexity of some of the interactions requires interdisciplinary collaboration, and also working with a range of stakeholders. It's great to be part of an event like today to co-create potential ways forward and hopefully solutions.
Thanks, David. Very insightful and also very interesting the way you have put those 5 points. We'll take this conversation further, but before I go over to the second round of conversation, I'll request all the people who are listening to us or who are seeing us, please put the question that you have in the question answer box there so that we will be able to take it up in the second round. In the last round is the question answer round, but you please start writing there so that I can take them up or group them if need be in the interest of time. So the second round, what we'll be doing is that we'll have some direct questions to the panelists and then try and seek, especially for understanding this whole phenomena from the larger public angle, in a sense that, how does it make sense to the normal people, not the scientists, not the academics, but people on the street. So Miriam, let me just cross over to you first, and the question that information that Ulkay shared about the op-ed from Swaminathan Iyer and looking at how Glacier contributes to water, but we also know scientifically how Glacier help in maintaining the base flow of the water in the rivers around South Asia. So can you just help us in understanding how and why are glaciers important for us? Just for the general people to know, why are glaciers so important? Why do we talk about them? Over to you.
Okay, thank you, Angel. Well, glaciers are important to us for very many reasons. We've already been through quite a few of those reasons here. And it's for people living close to them, but also even for those living very far away from them. One thing that's been mentioned is glaciers act as storage for water. It's a kind of savings bank. So in hot, dry weather, if you've got little rain, if it's hot, you need more water, then that's where glaciers sort of step up and, contribute water to the system. And that water is then used downstream. It's used for agriculture, it's used for drinking water, and it's also used for hydropower. So if you live in a country that has hydropower and glaciers, you're benefiting from this, even if you live a long way from it. Glacier ice has also been used as refrigeration, for example, for long-term storage of food for centuries, both by people living close to the glaciers, and it was transported as well. It's been used by animals as well to cool down. So it's already been mentioned, the fact that Ulka mentioned animals like cold water. And animals would even go on the glaciers themselves to cool down and get away from parasites. And then, people would hunt the reindeer on these glaciers and snow patches. And this was happening thousands of years ago. So, our symbiosis between glaciers and people has been going on for a very long time. And it's also very important to understand them in terms of hazards. So as glaciers change, a few things can happen, and sometimes water can collect at the side of the glaciers, or else in front of the glacier, between the glacier and the moraine. And this water can build up as the glacier melts, and then it's suddenly released in a big flood. It's often called a gulf. And when I say big, I mean, really big, like tens of millions or hundreds of millions of cubic meters of water. And imagine the devastation that this causes. But even small ones are problematic, even if it's only, 1 or 2 million cubic meters of water, a few 100,000, if you're in the way of that, that's going to have a big effect. And also as the flood travels downstream, then it picks up debris and causes even more problems. We've also found evidence, and a famous example of this, or two famous examples, were in Tibet in 2016, that glaciers can collapse quite catastrophically. And this is, something that people just didn't really expect a few years ago. And then again, there was the event in Chamali in Uttarakhand in February. And this was more related to rock, but also ice was involved. So it was a bit of a complex mixture, but it shows that, changes in the ice and changes in the temperature are having these big effects. Another thing that's been mentioned is sea level rise. So again, if you're a long way from glaciers, you can still be affected by sea level rise if you're living at quite a low elevation and close to the coast. And the biggest potential response to this is from Greenland and Antarctica. If you melt them, all the ice on the Earth, this is where most of the effect's going to come from. But just looking at the last few decades, it's actually what we call the smaller glaciers, which is actually everything outside of Greenland and Antarctica. And they've been contributing, about as much or the same as Greenland, or possibly even a bit more. So even though each individual glacier doesn't contribute much, cumulatively, they do have a very big effect. So people living close to sea level, and also infrastructure, docks, obviously, and also airports, that's obviously, all these things are affected by even small changes in sea level. I think glaciers are important. One of the most important reasons is it's a very visual signal of climate change. So we know that the carbon dioxide level is increasing, but nobody got up this morning and said, oh, there's a lot of carbon dioxide. It's a lot more than it used to be a few years ago. It's something you need instruments to measure it. It's very important, this effect, but it's not something that we notice. We know because we have measurements of temperature going back a long way that global temperature is increasing in some areas more than others, especially, for example, in the Arctic and at high elevation, the temperature is increasing. But then you get one cold day. It's happened in Melbourne recently in Australia. It had one of its coldest May days. And people say, oh, it's so cold. Obviously, global climate change isn't real because it's cold today. However, if you look at glacier retreat, it's a very visual signal that something is happening. And if you look at a photo of a glacier 20 years ago or 100 years ago, you can see something's going on here. And Caroline talked about that in her opening talk, her experience at Mer de Glace, and just how much has changed in a small number of years. So this is something that people can really relate to and say that something is happening and climate change is real. And as recently as about, I think, 15 years ago, a lot of scientists in India thought that the response time of glaciers to climate was very long, hundreds, perhaps even thousands of years. But we now know the response time is short. So the changes that we're seeing in glaciers now, this is a response to climate from just a few years ago or a couple of decades ago. Thank you.
Thanks, Miriam. Thanks. Let me just cross over to Ulka. And, Ulka, there is the days of climate skeptics in a sense that people who do not believe in climate change are over with the Trump's regime going. And I think that probably marked a kind of a despite change in the global policies. But still, there are a set of people who think that we are making too much out of an issue. Do you think there's a sufficient evidence that we have to conclude that these are all climatic events, or is there anything else that we do not know yet, or we are not exploring that much?
Thanks, Anjal. I think, thanks. I think the cause for skepticism comes from two fronts. One is we actually have parts of the country, parts of the world like the Karakoram, where there is anomalous behavior that some studies have pointed out, right? So all glaciers don't behave the same, they don't all melt at the same rate and all of that. The second reason for skepticism is so much else is changing, especially in our part of the world, right? We have so many more people doing so many more things. So it becomes important to separate out the natural or climate signal from the the immediate human or socio-economic intervention. Right, so I think skepticism or questioning is very, I think, valid. Given that, I think of it almost like a detective story, right? Like a murder mystery, where you have to piece together clues. Some clues are there in the present, and some clues are there in the past. In terms of the clues from the present, one of my colleagues in our US office, Kelly Levin, got the chance to visit Antarctica, and when she got there, she really almost saw like the the impact of a murder mystery, which is that there was blood on the snow. By that I'm being very dramatic. What I mean is that there is a kind of snow called red watermelon snow, and this is caused by a certain algae which changes its pigmentation in order to protect itself from radiation when the temperatures rise. So this is what is called watermelon snow. And it's a kind of feedback loop because darker snow will obviously melt faster. And so there's a study by Stephanie Lutz et al. In 2016 where they looked at 40 different watermelon snow sites across Antarctica and found indeed the melt rate is faster. The second kind of unexpected thing that she saw in Antarctica was green grass sea material, like just more plant material. And this is because you have more nitrogen that was previously trapped in the soil, and now that is decomposing because of warmer temperatures. So you do have some clues that are laid out in the present. But there are, of course, a lot of paleoclimatologists and others who go back and reconstruct past records. For example, Scott Overbeck has looked at tropical glaciers all over the world in Latin America and Africa. And I remember attending his very fascinating talk once where he showed that he went up to a tropical glacier. And as the glacier retreated, there were fossils of plant matter. So long ago, there was plant life there. And if you look back at the Earth's history, perhaps it was because the northern hemisphere was tilted towards the sun, and so there was more warming of the northern hemisphere in the summer season. The difference between what is happening now is that the rate of change, the response time that Miriam talked about, is much faster. It's all over the Earth, not just the northern hemisphere, and it's not just in summer as a result, it's round the year. There are other studies, for example, Rowe et al. 2021 paper has just come out, which tried to, again, look at this past record and attribute how much of it is due to climate change. And they said that a few decades ago, you might be able to say that perhaps 25% of the glacier mass loss that is being seen can be attributed to anthropogenic climate change. But now, if you look at the more recent record, you could almost say that it's all because of it, right? So that's a study from around the world. Maurer et al. From 2019 is a study for the Himalayas, where they've also looked at, satellite films from Cold War era spy satellites. So it's like going from a detective story to a spy thriller. They've looked at those images and they found that in the last 40 years, ice loss in the Himalayas has doubled in its rate. So I think there are a lot of different pieces of evidence that are coming out, which show that, the rate at which things are happening now are much faster and cannot be explained by anything other than anthropogenic climate change. Thanks. Thanks,
Tulka. The climate scientist, as always, very interesting thoughts from your side. Let me just cross over to David. And David, the changes in the glacial systems here, especially in the Hindu-Kush Himalayan region, and its impact on the water regimes of the rivers that it supports. What do you see how is this water systems in the region going to change, and what impact it would have on the lives of the people?
Thanks for the question. Yeah. So the HKH region is very diverse, so it's quite difficult to generalize. And there is documentary evidence, and we should be clear about this, that in some areas, including parts of the Karakoram, the Eastern Pamir, for example, the glaciers have not been shrinking at the rate that we've been talking about in much of the other discussion. However, saying that, the recent HKH assessment that was published by ICIMOD in 2019 concluded that even if we keep warming to just 1.5 degrees C, a third of the glaciers in the Hindu-Kush and more than half of those in the eastern part will be depleted by the end of the century. I mean, to give you an idea, glaciers that feed the Ganges, the Indus and the Brahmaputra have lost over the last 10 years on average 24 gigatons per year. So to give you an idea of what a gigaton is, that's 10,000 aircraft carriers. So we've lost 240,000 aircraft carriers worth of ice. And that accounts for 10% of the global glacier loss in the last decade. Caroline mentioned this is really important for people in terms of millions. Actually, the Himalayan glaciers alone provide water to 1.4 billion people downstream. And more locally, the retreating glaciers and shrinking snowpacks have really strong impact on high altitude communities that rely on them for domestic water resources. So I talked a lot about the impacts in my opening statements. And what I want to do here now is just to pull out some that are specific to the HKH region, some notable geographical variations. So it's expected that snow fall will decrease and that the snow line will rise in elevation, which will impact upon seasonal water storage. But it should be noted that there are some real challenges in modelling glacier change. And this is particularly true for when we look at glaciers covered with debris, which are common across the HKH region. And notwithstanding the sort of issues and uncertainties around the modelling, it's suggested if when we look at regional scale studies under moderate warming, that by 2030 we have a 9 to 32% loss of glaciers. By 2050, there's clear evidence of higher loss of ice, particularly in the eastern Himalayas. There is a spread of projections based upon some of the uncertainties, particularly around the future climate projections that then feed into the cryosphere and hydrological models. The loss by 2050 there would be between 25 and 36%. And by the end of the century, as I mentioned, there'll be really pronounced losses across the region, but particularly in the eastern Himalayas, of between 64 and 95%. As has also been mentioned, in the Himalayas, the precipitation from the monsoons really provides a deterministic, very predictable element to the annual flow cycle. Although it should be pointed out that when glaciers with snow and ice, there's significant seasonal buffering or annual buffering of this year-to-year variability. So, for example, our work in the Nepali headwaters showed that the basins, which had larger glaciarized areas, showed less year-to-year variability. So they're very, very important in terms of modulating that monsoon variability. But it's also been mentioned there still are significant questions around the contributions of snow and glacier melt. Partly what Uka mentioned about how you quantify that in terms of the contributions to stream flow. And we need to do more work to quantify this at the individual sort of basin scale. However, yeah.
I'm sorry, I have to just interrupt because there are a lot of questions pouring in. So I'll just cross over to, sorry for disrupting. Let me just cross over to Kunal first, just ask, and then we'll open it up for discussions. I'll just come back to you. So Kunal, this, you being a practitioner also, in a sense that you, the Himalayan states that are there, what do you see the impact of these changes, and not only glacier melting, but other climatic changes impacting the lives and livelihood of the people across the Himalayan region, especially in the coming from India, because you have a lot of experience from there. What do you, Kunal?
Yeah, so just adding on to what other panelists have already talked about, I think I will be speaking more at ground zero level, not at the global level. So if I take one river called Satluj River in Himachal Pradesh, very important river. Now Satluj River has around 556 glaciers, and they have receded by, almost all of them are receding. Number of glaciers are increased, in fact. Numbers of glaciers increased for the audience. If the numbers increase, it doesn't look like increase in forest cover or increase in tiger number. Increase in glacier is a bad thing. And the numbers have increased in glaciers across Himachal Pradesh, where I've worked for a very long time. So that is very important. And somebody raised about the importance of GLOF. I was looking at the figures of 2019 vis-a-vis figures of 2001. At times I used to tell my bureaucrats and politicians about the figures of GLOF rising, and they used to tell, don't give it to the media, because the numbers are scary. Number of moraine dammed lakes in Himachal Pradesh has almost risen by double in a decade. And they're setting time bombs. We can keep on saying later that Kedarnath tragedy happens or one lake has disappeared. I can scare you by saying there are so many lakes above 10 hectare area, between 5 and 10 hectare area, which should be monitored very, very regularly. Easier said than done. Satellites have their limitations. On ground zero, you can't reach these places. I borrow from Miriam's statement, you should see a glacier. A lot of people talk about glaciers, and I've never seen a glacier. And I've seen experts of glaciers who have not gone to a glacier. If you hike to a glacier in the Himachal Pradesh or in Uttarakhand, you'll feel very humble. They make you feel very little. You're not nobody in front of them. They are huge things. And from a cultural perspective, I've gone to some of the glaciers 10 years before and 20 years before. I was told to take out my shoes because you're not supposed to go into the glacier area because they were worshipped by local people. And to a small lake, if you go there, you have to take a dip every year and bring a plant of Sosuria, which is called Brahmakamal, back from there. But those were the days. Now that cultural disconnect from glaciers and lakes is enormous in the mountains. People have lost that connect, and a lot of people are talking about glaciers who have not gone to a glacier. So that is one small caution I thought I'll put there. But the numbers of moraine dam lakes, number of landslide and flash floods in Himachal Pradesh and Uttarakhand have risen drastically. much beyond imagination of local people. And the corollary, because everything develops in the mountains along the rivers. You know, every city or every religious place or every big town is along the rivers. People like to build hydropower projects come along the rivers.
Yes.
Yeah, sorry. So I think
Kunal, I have to just stop you because I have 5 minutes and there are a lot of questions that come, so I'll try and direct them so that at least we can cover some grounds on the conversation that we have. Yeah. So let me just, Miriam, there's one question I thought it's important for you to probably look at it. The question is coming from Bhaskar Shailesh, and he's asking, with the average temperature rising every year, what is the climate change going to be in Siberia in the next 100 years? And the follow-up question, which I'm not sure if you'll be able to answer, but it says, will it make Russia power with respect to climate? But I'm not. You can choose part of it to answer. The question is the rising temperature in Siberia, and what it will be like for the next 100 years. Miriam, over to you.
Okay, thank you, Angel. It's not really my field, but as I said, there is generally a pattern of a global increase in temperature, and this pattern isn't consistent. So it's going to be more in some areas than others. And one of the areas where it's more is in the high latitudes, so in the Arctic region. So the Siberia will get warmer than the global average. And this is probably good news for a lot of people. It's also bad news getting back to the permafrost. So if there's permafrost in these areas and there isn't over much of Siberia, then it's permafrost is going to start thawing. And building on that is a big challenge because you really have to take this into account.
Okay, I will request. Yes, I'm sorry, there was some break in your maybe internet connection. But anyway, I'll request you to be slightly shorter in your response because I'm trying to cover as much as ground in next 4-5 minutes. Thank you so much. David, there's a question about UK-India relationship and what are the opportunities from policy science and research side that you see this collaboration can happen between UK and India? Over to you, David. Very short answer, please.
Yeah, so I think that there's good potential for feeding sort of science into sort of policy and having sort of appropriate sort of interfaces there. One of the ways we're doing that, for example, is through the UNESCO Chair in Water Science at the University of Birmingham, and we've also just established a new what's called UNESCO UniTwin in hydroecological interfaces that includes colleagues based at IIT Roorkee. So I think it's important to have that scientific dialogue and then work through important influencing organisations to pull that through to appropriate sort of policy domains. So it's one thing to do the science, but we need to tell people about it and tell the right people about it to get and make sort of real change.
Thanks, David. Kunal, there's a question, a very provocative question from Harish, is asking about the private forest and then the Forest Act, which is introduced. So, you have any insight into that? Quickly, if you can just tell us.
As we call in bureaucracy, it is beyond jurisdiction and beyond the webinar topic. But I'll answer that private forests in India are still under the conceptualization stage at the ministry level and the stakeholder consultation. It has not seen the light of the day today. Vis-a-vis UK, where most of the land is held by private landlords, and India, most of the land is held by the government. And the community manages some of the lands in Northeast India. A lot of examples of community management of forests are available in India, but private forest is still a futuristic thing.
Yeah. Okay. Ulka, there is a question on by Apurva, and she's asking about the regulations of government putting on industries to stop climate change. And I remember reading one of your op-ed in Indian Express about net zero and why India should be going and how businesses are also should be contributing. So what is your thought, Ulka, on this?
So far, it is mostly voluntary. I think the only regulation that is there is the Perform Achieve Trade scheme, which is an energy efficiency trading scheme rather than a carbon trading scheme. Apart from that, voluntary initiatives by industries are not enough, especially the large industries like cement, iron and steel and others, which are the major contributors to emissions, do need to do much more in terms of switching eventually to a hydrogen-led economy, and to reduce process-based emissions in addition to energy-based emissions.
Thanks, Ulka. I just have left with 1 minute, so I don't want to spend more time. There's a lot of questions here, but probably that shows that there's an interest in the community on these questions. And we should probably do some more of these kind of webinars so that we can be more answerable to the people who have been asking these questions. I will not like to summarize, but it's a rich discussion. But just to see how we are, as we are preparing, the region is preparing for COP26. I think there's a lot of things that we can take home from this discussions and the conversation we had, especially in achieving the net zero by 2050. I guess the countries of our region should be actually going forward and pledging it, because the climate change is not only impacting our lives and livelihood, but also the economy and the day-to-day life for people. And you see the number of cyclones that has hit this continent in just last 2 weeks or 3 weeks has been devastating for many people. Forest resources and the water resources are at risk. So with this, I like to close, and then I thank everyone, all the panelists here, David, Kunal, Miriam, and Ulka for very insightful discussions. And over to you, Guru, for Remark. Over to you. Thank you so much.
Anjal, thank you very much. I think, the fact that we have had such an engaging audience and the questions, I was looking at the questions in the Q&A and the responses. I always believe that these webinars are good when they're ending on a high, when there's a yearning to do more and to listen to more of these things. So I think on that, just on that particular point, I think we're in the right spot. On my personal behalf, on behalf of the Indian School of Business and on behalf of the British Deputy High Commission, our partners for this event, I want to thank you, Anjal, for doing an excellent job of convening this panel and for doing this session. And to all our distinguished panelists, thank you so much for sparing time on a busy day to spread knowledge, to create awareness, and hopefully for all of us, as Anjal said, people on the street, to pick up some of this wisdom from you guys and to sort of hopefully, guide some of our own actions. Thank you very much. And to all our audience who have tuned in on Facebook and on the WebEx, thank you very much. I hope you found this session very useful and informative. Carolyn, thank you very much again. Thank you.
Thank
Bye.
you so much.
Thank you very much.